Right. So today's endeavor is the set down. The set down is basically the isolation of material mass and dropping it to create a plane shift between the top plane and the lower plane. So you're essentially trying to get something that is, say, cut in like this. Or if you're doing a two-sided set down at an angle, you might do a cut in like this. Hopefully the drawing makes sense. Nope, that would go. That's it. I got the views there. So something like that. So square bar, triangling down, then triangling out again. Okay, so that is something that we use for isolating out a leaf. The most important thing of this is you're generally pushing down from above into the anvil itself. So when you are doing so, that's cross section on my anvil, my material is here. I want my hammer blow to be striking half on and half off. That way the energy is pushing this down and compressing this. So as this comes down, it pushes up into that. Right? That is the theory of it. And I will do first off a near side isolation, and then I'll do a far side isolation, just from one side. Locking in nice and tight, laying it still, striking down. Feel for that shoulder. And that's good. Just evening out the material. That is a good solid isolation. My next isolation I'm going to do on the far side of the anvil. So about there. Put a little bit of a mark in it, so I know where it's going. And this will cut in this direction and then feather out like that. What is it useful for? Whenever you really want to cut out, make a volumetric change between material mass and non-material mass, this is really the way to do it, using set downs, using isolations. We use it in tongs. Tongs are essentially 3 set downs. Leaves are a single two-sided set down to isolate out the mass. What else? Jessica just mounted spoons behind here, so yeah, a spoon is basically the same idea. A knife, isolating a knife blade from the handle, that's another way to look at it. If you're doing an integral blade where it's isolated on both sides, and you are getting straight sections and it comes out into the bar stock like that, that would be a set down, two-sided set down. If you're cutting a tenon, you basically, you'll be mortise and tenon, and you're doing this, you're actually isolating that from 4 to 8 sides. Okay, so off to the other position, laying down fairly low, and I'm striking half on, half off again. Every time making sure I'm pulling back into my set, and I can move backwards. Work from above, and there we go. Little clean up.
Will you show both of those positions again so that they can see the whole body?
Position 1 is here. I've got it into my leg so it doesn't run away from me too much. I'm striking here. Position 2 is actually turn this way. Here. Go. But if, say, you were doing the lock mechanism, this might be one of the methods to isolate out a mass. Okay. So that's the basic principle of a two-sided set. Also a one-sided set. I'm now going to do a two-sided set. Two-sided, that's what this is, and where you would use that would be into a leaf format. I'm going to go grab a couple of sample rings. I've got a spoon and a leaf here. So if you look at the leaf progression here, that's your two-sided set down. It forms in on both sides, and that is cut in on the far side of my anvil there. If you look at that same idea of construct in a spoon, there you go, two-sided cutting to end with a spoon. All right. This one is elongated to make the neck. That's what it is. Hopefully I've talked enough and my material is fairly hot. No, not yet. This can be done either very low angle or very high angle. You've got to remember that your angle determines the shear face. Also, the radius of your anvil will determine the internal corner of your radius. You don't want to use too sharp of a corner, because then you'll wind up with a fracture, basically. You get a cold shut in there. So if you are holding your material at an angle like that and it's being hammered into a 90-degree corner, that's what you'll expect. If you're doing it more at a low angle, so let's call that a 10-degree angle, and you hammer it into a 90-degree corner, you get something more like that. And vice versa for near side. So if you're doing near side and you're very, very flat, you're going to get a L isolation, just simple like that. If you go low angle, you are going to get something like that. That makes sense? So, you know, how you hold that really determines a lot. Also, do you want a sharp corner or do you want a soft corner? If we're making a pair of tongs like these, you look at those internal corners and they're fairly soft. So I'm using something in the 3/8 of an inch radius. If I wanted something sharper and crisper, I might lay it in with a soft one at first, go back and soften it up, or go in straight from the beginning with a very harsh angle. Alright, here we go. Far side, two-sided. A couple of whacks to get a good bite in there. Turn, make sure you maintain position. Strike in. Turn back. And if you want to elongate your stem here, you can just lay it down. I always work with the set down facing downwards, so that I'm less likely, if I'm like this, I'm more likely to hit it and bend it. If it starts raising up like that, you're pulling back too far, so just give it a little bump. Do not work these necks overly cold. Do not aggravate them and let them twitch a lot, because they will fail on you. And that first time that you have a little thing that you spent so much time and effort working on just ping across the room, you'll be sad. So, I got a little off with my lines on those, but it's not too much of a big deal. That is the principle of it. So, single-sided set down, two-sided set down, which is essentially a square point. If you did that just as a square point hanging where you're hanging material too far, that's what you've got. Alright? And of course you can offset these, so instead of doing them on the same side, you can offset them, and then you'll have this kind of action. Right? Lovely.